Our last problem here is determine the area of the region enclosed by y equals sine of x and cosine of y equals cosine of x, x equals pi over 2, and the y-axis. So I need the y-axis, so I'm going to go ahead and use the edge of this tiny graph paper that we have here. So this is going to be x, this is going to be y. I know sine and cosine have a maximum of 1. So I'm going to go ahead and just say this is 1. And then I'm going to pi over 2. 3, 4, 5, 6, 7. 1, 2, 1. So I'm going to go right about here and call this pi over 2. And this right here is my stopping point. So between the y-axis and pi over 2, that is the area we're looking at. So for a sine graph, I know that I'm looking at starting at the midpoint, so starting at 0, 0, and then we go all the way up to 1, versus a cosine graph where I start at my maximum and then I go to 0. So we're looking at something that looks like this. And they cross at a very specific point, and that very specific point is going to be that unit circle value that makes sine and cosine the same thing. That unit circle value for in radians would be pi over 4. So this pi over 4 is going to be really important for us here, and that's because we have two areas again. So I have this area right here and this area right here. So things to remind ourselves, this is y is equal to sine of x. This one is y is equal to cosine of x. So when I look at this first area, this area in blue, we have the integral from 0 to pi over 4, because we start at 0 for the x-axis and go over to 4. So now we need to decide which one's on top and which one is on bottom. So if we look at this function, the cosine graph in this blue is the one on top because it's starting at that maximum, starting at 1 and going down. Sine is on bottom because it's starting at 0. So we are going to do cosine of x minus sine of x dx. This green area, which we're going to add to it, is the area from pi over 4 to pi over 2. And this is the point where we switch which one is on top and which one's on bottom. So I have sine of x being on top and cosine of x being on bottom. So now we integrate both sides. So I have the integral of cosine is sine of x, and we are integrating negative sine of x or minus sine of x. The antiderivative of sine is negative cosine, so either way we're going to get a plus cosine here. And this is evaluated from 0 to pi over 4, plus the integral of sine is negative cosine, minus the integral of cosine, which is sine, evaluated from pi over 4 to pi over 2. And this is where I would probably use brackets to make it really clear that we integrated both those pieces on that side. So I have sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0. And we're adding to that negative cosine of pi over 2 minus sine of pi over 2 minus negative cosine of pi over 4 minus sine of pi over 4. And this is going to require us to remind ourselves of unit circle values. So pi over 4 is a really nice one because they are the same no matter what. Pi over 4 is that 45-degree angle, and this is going to be our square root of 2 over 2. So we have the square root of 2 over 2 plus the square root of 2 over 2. We are going to be subtracting from that sine of 0 plus cosine of 0. Sine of 0 is 0, cosine of 0 is 1. To that, we're going to add negative cosine of pi over 2. Well, pi over 2 for cosine is 0, so if I make that negative, it's going to just still be 0. Negative sine of pi over 2 is 1, but because it's a negative sign, we're going to subtract 1. Minus negative cosine of pi over 4 and negative sine of pi over 4. And we know that those are square root of 2's over 2's, so we have negative square root of 2 over 2 minus square root of 2 over 2. Okay, square root of 2 over 2 plus square root of 2 over 2. I have 2 of them, so that would be like saying 2 square root of 2's over 2's. Square root of 2 over 2 here cancels each other out with the 2, so 2 divided by 2 is 1. So our full thing right here simplifies to the square root of 2. From that, we are going to be subtracting 1 because 0 plus 1 is 1, and we're subtracting. To that, we're going to be adding 0 minus 1, so negative 1 minus, and we have the same thing. We have 2 negative versions of it. So we have negative 2 square root of 2 over 2. The 2's are going to cancel each other out, and our minus and negative is going to turn it into a positive. So all of that being simplified together is plus the square root of 2. So we have square root of 2 minus 1 plus negative 1, or minus 1 again, and plus square root of 2. So we have 2 square root of 2's, and we have minus 2. So our area here is 2 times the square root of 2 minus 2.